Just start recording. We'll just try to summarize all the important laws and rules that we are using in Unit 5 in the kinetics, and then we'll start solving some questions, inshallah. We know that the reaction rate simply, we find it, this is the reaction rate, so this is going down. No. Okay, so the reactions rate mainly is found by, right, rate of any chemical equation. If you have the rates, the rate of any reaction is equal to the division of the change in the concentration. So the concentration change, which we sometimes write as delta C, or change in the concentration, or I can say it is equal to the concentration at time 2 minus concentration at time 2 minus concentration at time 1 of the substance, and I will divide this by the change in the time. So it's a change in the time, so it is the time 2 minus time 1, or T2 minus time 1. So this is the change in the concentration per unit time, or the rate of the reaction. And because the concentration unit, so we try to find the unit for this one, because the concentration unit is equal to mole per liter, or mole per decimeter cube, or molar. So I will say that it is mole per decimeter cube, and then I will put the time, bottom here, per time. And I can write this in many different ways. I can just write mole, decimeter cube minus 3 time minus 1, or I can say molar time minus 1, like that, or I can write it in different ways, but this is the basic ways to write the units of the change in the concentration per time, which we call the rate of the reaction. The second thing that we need to revise after the main law is that the changes in the concentration of reactants are related by the reaction stoichiometry. So we were saying in the stoichiometry, if the reaction, I have a reaction, for example, A plus B give me C. So the number of moles, if this is 1 mole or 2 moles and 3 moles, are going to define the rate of the reaction. So for example, if I have one reactant which is made of 2 moles and I need to find the rate, so the change in the concentration by increase or decrease will be depending on the number of moles, as we will see in the examples. There is a very easy part that we will usually skip, but we'll say very fast, that what are the factors that affecting rate of the reaction. And we know that the factors that affect the rate of the reaction affecting the rate by increase or decrease are as follows. The first thing is the temperature. Increasing the temperature for sure increases the rate of the reaction, and decreasing it is the opposite. And the concentration of the reactants only, of course, not products, concentration of the reactants, which we'll write it between brackets. Increasing also the concentration increases it, and decreasing it decreases it. The catalyst, presence of the catalyst increases the rate of the reaction. And the nature of the reactants, What is the meaning of the nature of reactants? If the compound is a simple compound, if I have CH4 and the CH4 is trying to react, you need to break 4 bonds only. So all you have to do is to break 4 bonds. But if you have a very complicated structure, and this molecule is trying to react, then this structure, you have a lot of bonds, like have 100 bond or 200 bond in one molecule, and you need to break this in order to react. Then of course it will take longer time. One more factor which affects the rate of the reactant is the nature of the solvent also. So the nature of the solvent, if you are dissolving in a certain solvent, this will affect the rate of the reaction. And the last thing, in the case of solid reactants, how big or small the particles. So the particle size. If the particle size is smaller, then the rate of the reaction is going to be more. If the particle size is big, then the rate of the reaction is going to be bigger. Okay, one important note here is that some of the students think that the volume of the solution will make an effect on the rate of the reaction. Like, for example, if I have a solution which is 1 molar and it is 1 liter, and then in the exam I'm saying that this 1 molar solution I have 0.5 liter from 1 molar. Okay, what did I change here? Did I change the volume or I changed the concentration? I changed only the volume. So I did not change the concentration. So take care, because many of the people will fall for that in the exam. If you did not change the concentration, then there is no effect on the rate of the reaction at all, because at the end it is what? It is the same concentration. So changing the volume of the solution does not change. So there is no change in the rate of the reaction, because you did not change the concentration, you just changed the volume. Even if you make it half, if you make it less, if you make it a very small volume, still it is having the same concentration. زي بالظبط the example that we are saying, if I have a big pot of tea, and then from this pot of tea you are making cups of tea. So although the cups of tea have a smaller volume, but they are as concentrated as the big pot of tea. So if the tea is too much concentrated, then the cups of tea will be concentrated also. They will not be diluted. You did not add water to them. So the number of moles of tea did not change. It's only a less volume. Even if the volume is smaller, the concentration is still the same. The only change that will happen and causes the concentration to change if you added water. So if you added water to these cups of tea, then you are changing their volume, or what you are doing to it, you are making dilution. In this case only, I have changed the concentration, then the rate of the reaction is going to change. Please take care of this point, it's very important. Okay, what about the relationship between the reaction rate and the reactants and products? We said if I have a general formula, so if I have a general formula, like I have, for example, a reactant which is called A reacts with another reactant which is called B to form a product called C and D, and then we will say general number of coefficient, like the coefficient is alpha for this one, and the concentration for this one is beta, and this concentration for this one is delta, and this one is gamma, for example. So how can I find the rate of the reaction? The rate of the reaction, we know that it's equal to the change in the concentration of A over the change in time. So change in time. But again, is this related to the coefficient or no? Yes, we said it is related to the coefficient. So for example, if this is 1, I will say it's equal to -1. But why it is negative? The change in the rate of the reaction will be negative always in the reactants. So if it is in reactants, I will see that this value is negative. And if it is in products, it will stay positive, so I will not put this negative sign. So where I'm going to put this negative sign, the negative sign will be always placed in the reactants if I'm calculating the change in the rate of the reaction for the reactants. Why is that? Because the concentration for the reactants is decreasing or increasing? Is the concentration of the reactants increasing or decreasing? Anybody? I have any reaction and the reactants, what happens to them? Do they increase in the concentration or decrease? They are going to what? Decrease, right? Yes, they are going to decrease. So if they are going to decrease, like for example, I have concentration at the end 50 and the beginning was 100. This means that the change in concentration will be -50. So this means that the rate will be in negative. So I don't want the rate to be in negative. It makes no sense when I say the rate is negative. It's like when somebody is asking me, what is the speed of your car? So I will say -50 kilometers per hour. That doesn't make any sense. I have to say 50 kilometers per hour. So instead of saying negative, I will make a negative value here. So this will be the negative of the negative. So the final rate will be in what? It will be in positive. That's why in the case of reactance, I will put negative. So I will say negative 50, right? So I will say negative 50. So the rate will be positive 50 at the end. So again, this negative, when I'm calculating the rate of the reaction for the reactants, I don't need to do this for the products, right? Do I need to do this for the products? No, I don't need to do this for the products. Why is that? Because the products already, there is a change, which is like I was 0 at the beginning. So I was 0 at the beginning and I become 50. So the final concentration is more than the initial concentration. So final here is more than the initial concentration. So the result will be already positive 50. So I don't need to make the rate in positive. I will say that the rate is equal to what? The change in the concentration. So it's equal to the change in the concentration equal to change in the concentration of C or D, of course. Here A or P is the same, over the change in the time. So I don't need to put the negative that I put here in the reactants. What about the coefficient? Do I need to make a value for the coefficient? Yes. So if the coefficient is alpha, it will be 1 over alpha. Like what if I'm finding the concentration of the change in the rate of the reactant relative to the P? So I will say negative again. Why? Because it is reactant. Negative beta. Beta stands for any number. So if it is 2, this will be negative 1 over 2. If this is 3, this is negative 1 over 3. And don't forget the negative every time. Okay. And then in the case of the products, it will be the same. The only difference in the products is that I don't put the negative, but still I will put the change in the concentration normal over the change in the reactants. So I will say it's equal to positive. So it's equal to positive 1 over delta change in the concentration of C over change in the time, equal to, again, positive or a negative. Is it positive or a negative? Positive. 1 over gamma, change in the concentration of delta divided by change in the time. So every time you are trying to find the rate of the reaction, just say 1 over the coefficient. 1 over, what if it is 1, then 1 over 1. I don't need, so you have just to divide by the number of the moles of the, or the coefficient of the reactants. Or in case of the products, it will be the same over the change in time. The only difference is that it will be positive instead of negative. And we understood why we are putting it as negative in case of reactants, so that the final result will be always in positive. So the rate of the reaction has to be in what? The rate of reaction has to be in a positive value. Don't ever say negative in the rate of the reaction. How can I measure the rate of the reaction? How can I measure the rate of the reaction practically? So rate of reaction. Practically, how can I measure it? I can say that by calorimetry. So calorimetry. So if I made a reaction in which a precipitate is formed, for example, and I see a yellow precipitate, and this amount of precipitate is formed in 1 hour, this is a very slow reaction. But if the same precipitate is formed in 1 minute, then it is a very fast reaction. So instead of forming the same precipitate in 1 hour, it's formed in 1 minute. So it is a fast reaction. But Mr., I cannot depend on my eye. That's why some devices, like the one we use in the Beer-Lambert law, are able to measure the concentration of the solution by the color. So some devices can measure how strong is the color formed and what's the color formed. So I use certain devices to measure. I will not depend on my eye, because the difference in sight will differ. Okay. The second thing that I can measure the rate of the reaction is by titration. So I can use titration. The faster the titration happens, the faster the rate of the reaction. And then there is very famous thing is the volume of the gas. Volume of the gas, and the best thing to measure the volume of gas produced is the How can I measure the volume of the gas produced? By the gas syringe. So if I made a reaction and the volume of the gas produced is 10 decimeter cube in 1 minute, is much slower than if 20 decimeter cube is produced in 1 minute, which is slower than 30 decimeter cube per 1 minute, like that. I can make a graph. I can always make a graph and see in the graph, compare the graphs to each other. So I can see what is the volume of the gas produced and compare it. Sorry, it has to be in y-axis for sure. So it has to be in y-axis, so I can see the volume of the gas produced and compare it against time. So for example, at 0 times, there is no gas produced. As the time passes, the volume of the gas produced starts to increase. And then finally, I will reach a certain plateau where there is no increase in the volume because the reaction has stopped. And the reaction has stopped, why? Because the reactants has finished. So once the limiting reagent is totally consumed, then the reaction will stop and then there will be a plateau. There is no change in the volume of the gas produced anymore. Then I will see another graph, like the first one was the blue one. Then I will see the red one, for example, will be a little bit faster. How do I will know it is faster? How I will see the curve? What will the curve look like? Anybody? What will the curve look like if it is faster reaction? What will that look like if it's a faster reaction? It will be steeper or less steep? The curve will be steeper curve. So if the curve is steeper, means that the rate of the reaction is faster. Why? Because here after 1 minute, only 10 decimeter. If I see here 1 minute, I will see that there is 10 decimeter cube, for example, formed. So at 1 minute here, there is 10 decimeter cube formed, while in the second curve at 1 minute, there is more volume formed. So I will see that the volume is 20, for example. And then the other curve will be, even more steeper, but I will notice that all the curves will end at the same place. So I will see that all the curves will end at the same place. Why all the curves end at the same place? Because the limiting reagent amount is the same. So the limiting reagent amount is the same. So if I have 3 reactions, they have 3 different rates of reaction, they will be faster curves. So there will be steeper curves. This is the steepest curve, which means it is the it's the fastest thing. But at the end, they all end at the same level. Why they all end at the same level? Because the limiting reagent have the same amount. What does this mean? Yani, for example, if I have a reaction between HCl, this is an excess reagent, reacts with calcium carbonate to form calcium chloride and water and carbon dioxide, of course, with the balance. So this will be Cl2, and then it will be balanced. The volume of carbon dioxide is measured after 1 minute, 2 minutes, 3 minutes, 4 minutes. I will notice that at a certain time, the curve will be the same for all the reactions, even if it has a past curve. So there will be a plateau. Why, Mr.? Because the calcium carbonate, which is the limiting, has been consumed. So even if you add, even if the reaction is faster, the volume of the gas produced will be the same at the end. Why, Mr.? Because this is finished. Even if you are faster, then let's say that you will produce a maximum of 60, right? Because what happens if you are fast and the reactant limiting reagent is small? Then even if if you are faster, then the limiting reagent is small, so it's consumed. خلاص, ايه الفايدة? Even if I am fast, then the reaction has already stopped. The only thing that I will see is that the rate of the reaction causes to produce a higher curve. When the higher curve is produced, if I have more limiting reagent. Yani, Mr., instead of having 5 grams of calcium carbonate, I have 10 grams. In this case, the volume produced, instead of having only 60 milliliters or 60 centimeter cube of the gas, I can produce, for example, 80. The numbers does not make any sense, by the way. The numbers does not make any sense. I'm just making up the numbers. So the curve will be not only steeper, but higher. So higher means what? Higher means I have produced more volume of the gas. Why did you produce more volume of the gas? I produced more volume of the gas because I produced more volume of the gas, because I have more limiting reagent to react. طيب, what if I increase the amount of the HCl? Is there any increase in the volume or no? Increasing the excess reagent. Does the curve become higher or still it is at the same? The curve does not become higher. So increasing the excess reagent does not cause the curve to be higher. Cause the curve to be higher. Why, mister? Because you already finished your limiting. What is the benefit of having more excess? If I added 5 grams and there is 10 milliliters, the reaction will stop. But if I added 20 milliliter, still the limiting reagent has finished, mister. So there is no point of adding excess. Still the reaction has stopped. The reaction time does not depend on the excess reagent. It depends only on the limiting. If the limiting is finished, so the reaction is finished. The last thing after the measurement of the titration by calorimetry or by titration or by the volume of the gas, the last thing is the pH. So if I change the pH of the reaction, this means that the rate of the reaction also can be measured. So less pH or higher pH will tell me if the reaction is fast or slow. Why is that? Does anybody know what is the relationship between measuring pH and measuring the rate? Anybody? What does the pH measurement means? It has a relationship with what? The pH measurement, it has a relationship with the what? With the concentration of what?
Concentration of hydrogen.
Of hydrogen ions, very good. So concentration of hydrogen ions. If you're Mr. saying that the pH is less or more, this means the concentration of H plus is less or more. So if there is less or more H plus concentration, the rate of the reaction is going to be faster or slower. So for example, if you are reacting HCl, which is 0.1 molar, the rate is slower than if you are reacting at concentration of HCl 0.2. So if you put 0.2 means higher concentration, means of course higher rate. So if you found that the pH is less, this means that the rate of the reaction will be, of course, higher. طب هنا I have less concentration, so the higher, so this is higher concentration. I'm sorry. Higher concentration means, the higher concentration means lower pH, and lower concentration, that's correct, means higher pH. So the rate of the reaction, of course, will change. That's why I can still use the pH measurement to find out if the rate of the reaction is fast or slow. One more point is that I can find the rate of the reaction from a curve. How can I find the rate of the reaction from the curve? Mister, you said the rate of the reaction is equal to the y-axis, which is the concentration change versus time change. So if this is a curve going like that, and you measure the concentration change, the concentration at the final time was here, and the concentration at the initial time was here. So this is concentration at time 2, this is time 2, and this is the concentration at time 1. So this is time 1. Mister, you said that the rate is change in the concentration, right? So that's concentration 2 minus concentration 1 divided the change in time. So this is time 2 minus time 1. But what is that, Mister? Isn't that the slope? Isn't that the slope of the curve? So this is the slope of the curve. The slope of the curve is equal to the change in the y-axis, which is change in the concentration, over the change in the x-axis, which is the change on the time. So this means that I can find the rate of the reaction by finding the slope of the curve. Just look at the tangent of the curve, and then you can find that the change in the concentration over the change the change of the time, which is the rate of the reaction. Okay. Regarding the rate of the reaction, there is two types of rate law. The rate of the reaction can be found by the rate law, and there are two types of rate laws. One is the differential rate law, and one is the integrated rate law. So the first one is the differential rate law, and the second one is the integrated rate law. So integrated rate law. What is the difference between them? The differential rate law, or sometimes we just call it the rate law. Sometimes we just say this is the rate law. It will tell me what is the rate depending on the concentration. So أول يا مستر, first, before telling me what is the types of rate law, tell me what's the rate law. The rate law is what helps me find if the rate of the reaction is changing or not. Until now, we are just speaking about what? We are just speaking about the rate law. It's the change in the concentration. زي ما بتكلم على السبيد بتاعت الكار. It's change in distance. So أنا كنت في المسافة ديت. I was in this place and then I became in this place. In what time? Then I will see what is my distance that I have covered in what time. The rate of the reaction is the same. What was your concentration at the beginning and what was your concentration at the end? And then divide this by time. This will tell me what is the rate law. But does the rate change or no? Same like the car. أنا كان ممكن يكون عندي speed at the beginning. I have a certain speed and then another speed become more or less, right? I can have a higher speed. So my speed can change while I'm driving. The same thing is also in the rate. So the rate of the reaction itself might change, right? I might have a slow rate at the beginning and then a high rate. Like in the normal curve, in this curve. Is there a change in the rate of the reaction or no change? Huh? Can anybody tell me? Does the rate of that reaction change, or is it the same through the reaction? Like, for example, if I find the tangent here at the beginning, is it the same as finding it at the middle of the reaction? Is it the same as finding it here, or it is different rate of the reaction? Can anybody join and tell me? Does the rate of the reaction changes, or it is the same rate? Yeah, it is different. Very good. It changes. It becomes less or more. Does the rate of the reaction become less by time? Or it becomes more? Yeah, it becomes less. Very good. So at the beginning, the rate of the reaction is very high. Why the rate of the reaction is high at the beginning?
There's more reactants.
Yes, there is more reactants. There is more limiting reagent. There is more concentration. Very good. So there is more reactants means that there is more concentration. So it means that there is more concentration of the limiting reagent. So this means that there is more rate. Type after that, slowly, the rate of the reaction decreases because my limiting reagent starts to drop down and decrease. That's why, for sure, my rate of the reaction will be less. And what happens at the end? What happens at the end? The rate of the reaction will become zero, yeah, mister. It becomes zero. Why it becomes zero? Because the rate of the reaction is equal to change in the concentration, and there becomes no change in the concentration. Yani at this point, the concentration final is the same as the concentration initial, right? There is no change. So there is zero. So there is zero. So zero over the time, there is no change. So أنا كنت في الأول بتكلم the first part of the lesson, I'm talking about the rate of the reaction. Now I will be talking about the change in the rate of the reaction. Does it itself change or no? I will know the change from the rate laws. أنا عندي حاجتين, حاجة اسمها differential rate law, two things, the differential rate law and the integrated. The differential law show you how the change زي اللي احنا كنا بنتكلم عليه دلوقتي. How the rate depends on the concentration. How the rate of the reaction depends on the concentration. If the concentration is high, the rate of the reaction will be higher. If the concentration is low, the rate of the reaction becomes lower. أمال الانتجريتد لو is different. It shows how the rate of the reaction depends here. It depends. احنا قلنا الأولاني depends on what? How the rate depends on time. هنا الريت depends on الريت depends on concentration. الريت depends on the concentration, if the concentration is lower or higher. Integrated will show me how the concentration depends on time. How concentration depends on time. We'll see it on time. ازاي يا مستر? Let me tell you. So simply I can say that the differential rate law has general formula. So it has general formula. For example, if I have two reactants, one reactant is A and this is its concentration, and the other one is B and this is its concentration, the rate of the reaction is equal to K. What is K? What is K? K is the reaction constant, is the rate constant, right? We call it the specific rate constant. So this is a fixed value. This fixed value depends on what? It depends on the temperature. It depends on if there is or there isn't, a catalyst, and what is the nature of the reactants itself, and what is the nature of the solvent. So again, what is K? K is the rate constant. It depends on what? What is the temperature? If the temperature is changed, the rate constant is going to change. Second, it depends on if there is catalyst or no. So if the reaction K is a certain K and you added catalyst, then this is going to be faster. And third is the nature of the reactants, and fourth is the nature of the solvent. Does it depend on the concentration of the reactants or not? Yes, of course, it depends. So I will say that the rate law is equal to K multiplied by the concentration of A and multiplied by the concentration of B. Every one of them is raised to a certain power. So it's power N and power M. Okay, one question. Does this depend on, or it doesn't, on the coefficient of the reaction? Is there any relationship between the N and M and the coefficient? Any relationship between N and M and the coefficient, or it has no relationship? Mister, we know that it has no relationship. Only there is one case in which it has a relationship. Can somebody tell me? ايه الحالة الوحيدة? What is the only case in which the N and M has a relationship to the coefficient? يعني يا مستر؟ يعني if I'm giving you a reaction, N2 reacts with H2 to form NH3, and then to balance this will be 2 and this will be 3. هل في علاقة؟ can I say that rate of the reaction is equal to K N2 to the power of 1 H2 to the power of 3? Can I say like that? Can I say like that, Abdu? Can I say like that? Does it depend on the coefficient? No, mister. It has no relationship with the coefficient at all. So I cannot say like that. So it has no relation with the coefficient. أمال ليها دعوة بإيه? How can we find it out? How can I find it out? People, and I know you are fasting. Okay, some of you are fasting, so just try to participate, huh? Hi, Mister. It has a relationship to what? How can I find it? I can find it only experimentally. So I can find it only experimentally. I can just find the concentrations and see how they have changed. And then I can find out what is this power. Is it power 0? Is it power 1? Is it power 2? If it is power 0, what do I call the reaction? I call this reaction has 0 order, right? 0 order. So if the reaction rate does not depend on 0, because power 0 means what? If it's N2 to the power of 0, it means this all will be cancelled and will become 1. So it means it does not depend on N2, right? صح ياسين? So it does not depend on N2. So this means it is 0 order relative to the concentration of N2. Huh? So can I say, Abdurrahman, can I say that the rate of the reaction depends on N2 or not? Hey, Abdurrahman, can I say the rate of reaction depends on the concentration of N2? No,
No.
no, very good. No, because it is to the power of 0. Okay, what if I say it is first order to the H2? First order to the H2. So, Miriam, I will say, what I will say, does it depend on the concentration of H2? Yes, yes, it will depend on the concentration of H2. But what does it mean H2 to the power of 1? What if I said H2 to the power of 2? What is the difference? What is the difference when it is power 1 and power 2? It means, yeah, Mr. Any change you mean to the concentration of H2 will happen to the rate. So, for example, if you multiplied the concentration of H2 by 2, the rate of the reaction will be multiplied by 2. If you multiply the concentration of H2 by 3, the rate of the reaction will be multiplied by 3. If you divide it by 4, then the rate will be divided also by 4. That's why I said this law show you the reaction rate, how it depends on the concentration, Mr. How it depends on the concentration. Okay, very good. What about the second order? What does it mean to have a second order? It means it's to the power of 2. So whatever change you made in the concentration of the reactants, whatever change you made to the concentration of the reactants, what will happen to the rate of the reaction? The rate of the reaction will be powered. So this change will be powered. So if you multiplied the concentration of reaction by 2, what happens to the rate of the reaction? Huh, guys? What happens to the rate of the reaction?
Multiply by 2.
Multiplied by 2 if it is first order. But what happens to?
Multiply by 4.
Multiplied by 4. Very good. How did you get the 4? You said
2 power of 2.
2 to the power of 2. Very good. Thank you so much. So whatever change you will do to the concentration, this change will be placed and then powered to 2. Very good. Thank you. Type. What if I multiplied it by 3? What will happen to the rate? This change, I will write it and then I will power it to 2. So this means that it will be multiplied. The rate of the reaction will be multiplied by what? The rate of the reaction will be multiplied by what? By 9, yeah, Mr. So the rate of the reaction will be multiplied by 9. Yeah, so again, the change that will happen, I will take it and power it to 2. Don't say do it by 2. No, I will power this change by 2. So it was 3 to the power of 2. And what is 3 to the power of 2? Is 9. Okay, so I divided the concentration by 4. I divided by the concentration by 4. So 1 over 4 to the power of 2. So what is 1 over 4 to the power of 2? Calculators, mind, what's 1 over 4 to the power of 2? Means 1
over 16.
Over 16. Very good. So the rate of the reaction will be divided by 16. So if you divided the concentration by 4, the rate of the reaction will be divided by 16. So whatever effect you are making to the concentration, you will take this effect and power it by 2. The same effect. So here it was multiplied by 2. I take it to power 2. 3 to the power of 2 divided by 4. So 1 over 4 divided to the power of 2. While if it is first order, I will make it the same. So here, I'll not change it. Here, multiplied by 2. Here, multiplied by 2. So here, I did the same. I multiplied by 2. Here, I multiplied by 3. So I multiplied the rate by 3. I multiplied the concentration by 4. The rate is also multiplied by 4. Okay, again, the concentration is independent of the reaction coefficient. Please tell me this more and more and more. Very easy rule. The rate of the reaction, so the exponents that I wrote, the exponents like n and m or whatever exponent, is independent. It does not depend on the concentration. Does not depend on concentration. Again, I am asking the same question. Where is the case that when I look at, what is the case that when I look at, I can try to find the rate of the reaction, the exponent from the coefficient. حد يعرفها? Does anybody know it? What is this? Mr. When I'm talking about the reaction mechanism, right? Don't forget, when I'm talking, صح. When I'm talking about the reaction mechanism, which step exactly I can use? Somebody tell me which step I can use. Which
Slowest step.
The slowest step. Very good. What do I call the slowest step? We'll come back to this and explain. I call it, what do I call it? The rate limiting step. The rate limiting step, صح? You were going to say that? The rate. In the rate limit. Sorry?
Determining step.
Yes, the rate determining step, and it is the correct one. It's not limiting. Sorry, you are correct. The rate determining step. I am wrong. You are correct. The rate determining step is the step that is usually the low step. This will tell me the whole reaction. It's called like that because it determines the whole reaction rate. If the step is slow, the whole reaction is slow. If the step is fast, then the whole reaction is fast. طيب, what is the relation between what you are saying, yeah, mister? What is the relationship between what you are saying and the rate of the reaction? Mister, I'm saying again, if you are talking about the slow step, you can go and cheat now. You can go and cheat and say, oh, mister, this is N2. Let's say this is N2, 2. In this case only, I will say the rate law is equal to K N2 to the power of 2. خدت بالك? Take care. This is the only case in which I can borrow the coefficient and use it here and say this is the power. مش في أي step في reaction mechanism. Only if the reaction is divided into mechanisms and only in the rate determining step. Actually, this is the only way that I can find the rate of the reaction in the question exams from. طيب, what is the overall order of the reaction? If you have a reaction rate which is, for example, first order, so I will say the rate is first order for the first reactant. A is first order. We can write the one without the one, right? يعني مش لازم اكتب الواحد. We know that usually in chemistry I don't write the number one. طيب, what if it is first order relative to the first reactant and second order to the P? Mister, what does it mean? Mister, it wants to say that the rate of the reaction changes during the reaction. The rate of the reaction changes during the reaction. It depends on what? What? It depends on the concentration of A and B, or it does not depend on them. Abdurrahman, which one? It does not depend on its concentration. A or B or C? Which one? It does not depend on its concentration. It does not depend on C. Why, mister? Because it is zero order. Mister, actually, when you are putting this like that, it will not show. It will not even show because C to the power of 0 is equal to 1, actually. So it will be written as that only. Okay. أمال إيه reactants? What are the reactants on which it depends on? Only A and B. What happens when you double the concentration of A? What happens to the rate of the reaction? When you double the concentration of A, what happens? حد يقول لي, what happens to the rate? The rate is?
Multiplied by 8.
لا. A, in case of A.
Oh, A? Multiplied by 2.
By 2. Why did you say 2? Because it is first order. First order, يا جماعة. First order means whatever you do in the concentration, the same happens to the rate. Okay, طيب, what if I said it is multiplied, the P is multiplied by 3? What happens to the rate? Is it multiplied by 3 ولا 3 to the power of 2, Abdurrahman? Is it multiplied by 3 or 3 to the power of 2? In case of B, 3 to the power of 2. Why? Because, very good, because B is what? Is second order, because B is second order. What if he told me what is the total rate? Mister, then if the total change here is that I will multiply the rate by 2, then multiply it by 3 to the power of 2. and then any changes that happens to C does not make any effect. Any change that happens to C does not make any effect. Why? Because it is zero order. It will not even be mentioned, dear Mr. in the rate law. طيب, what is the overall rate law? What is the overall rate law? The overall rate law, how do we find it? How do I find it? By what? By what? If I told you what is the overall rate law, Miriam, what is the overall rate law? By addition, right? By addition. So if it is first order and second order, what is the overall order? The overall order is 3. Is 3. Bravo. So all you need, very good. So all you need to do is just add them together. Okay. So I can use the initial rate method. I can use something called the initial rate method. What is the initial rate method? Mr. Because he said that this is the first type of rate law, I can find the changes that happened in the rate of the reaction depending on the initial concentration. Depending on what? It's called the initial rate method because it depends on the initial concentration. You see what was the initial concentration and what it did become. Mr. How do we do this? I just did this now. Do you remember? I told you this was the concentration A, and then I multiplied by 2. So I was talking about what? What I was talking about? The initial concentration. So if your concentration was 1 molar and it become 2 molar, أنا بتكلم على إيه يا مستر? I'm talking only about the initial concentration. It was 1 molar and it become 2 molar. So what will happen to the rate? It will be doubled. How did I know it is doubled? How did I know it's doubled, Miriam? Because the concentration was doubled. So the rate will be also doubled. But if the concentration was 1 and become 3, so this means that the concentration of B has tripled. Then in this case, what will happen to the rate? It will be multiplied by 9. Why 9, Mister? Because it is tripled and this is second order. So 3 to the power of 2. So he will give me some concentrations, he will give me some experiment and some concentrations and ask me about the rate law. And he will ask me about the rate law. Like what, Mr. Like this, for example. This is, I have a reaction, let's have a reaction. This is nitrogen monoxide. So this is nitrogen monoxide, and this nitrogen monoxide reacts with hydrogen to form nitrogen and water. So he will give me the initial concentrations. You see, it's called initial. That's why it's called the initial. He cannot give me multiple concentrations. I will be confused. But he just give me the initial concentrations and then ask me what happens. And then ask me what happens, Mr. in the rate of the reaction. Then I have to see one of the reactants fixed. لازم أعمل إيه? I have to make one of the reactants fixed and the other one changing. So I will just stop one and move the other. Move the other one. So what does it mean, Mr. Boss? Look here in the P, the NO, does it change? ما بين experiment 1 and 2, Abdurrahman, does the concentration of NO change? It was 400 and it become 400. It was 400 and become 400. There is no change. But the other one changed. What happened to the concentration of H2? Anybody tell me? What happened to the concentration of H2? It's almost what? Halved. It's almost halved. While the first one is constant. Why are you doing that, yeah, Mister? Why are you doing that? Because I need to see between experiment 1 and 2, what happened also to the rate. What happens to the rate? The rate has also been what? Anybody, what happened to the rate of the reaction between experiment 1 and 2? Mister, I don't take 3 experiments to compare. I just take 2 experiments. أشوف في الأول what was the rate when I had the experiment 1 and when I changed the concentrations, what happened? So I take 2 experiments. At the here the concentration was 289, and in the second experiment the concentration was 145. For example, this one, the first concentration, and this is steeper, right? or it is less steep? It become less steep, yeah, mister. How did you know it become less steep? Huh? Because the rate of the reaction becomes slower. It was 160 millimeter Hg per minute. It becomes 0.80 millimeter Hg. So it is half. Okay, mister, very good. So you told me it is halved here for the concentration and it is halved for the rate. So what rate law is this? Is this zero order ولا first ولا second order? Is it zero order ولا first ولا second? Let me remind you. If there is change in concentration, no change in the rate, what order is that? Zero order. It is zero order. If the change in concentration is the same change of the rate, it is first order. If the change that happened in concentration caused the rate to be powered by 2, it is second order. طب حد يقول لي, somebody tell me, is this the same change or powered or no change at all? Mister, I see here the concentration of H2 is what? The concentration of H2 is what, ya Abdurrahman? It is halved. What happened to the rate? It's also halved also. So is it the same or the power 2 ولا it's no change? Mr. I see it is, it is what? في ناس كتيرة جدا, many of the people when they look at this one they are confused. They will say it is halved يا Mr. So no change. خد بالك, I'm not telling you about no change ما بين the concentration والrate. I'm telling you what happened to the rate of the reaction. خد بالك, many of the people that I'm explaining to them they get confused. They will tell me no change. ناس كتيرة جدا بتقول لي no change because this is halved and this is halved. خد بالك, I'm not comparing ما بين concentration وريت يا ياسين. I'm not comparing ما بين concentration and rate. I'm comparing ما بين what? The rate at the experiment 1 and the rate experiment 2. What happened to the rate يا عبد الرحمن? What happened to the rate? Is it changed? ولا not changed? It's halved يا مستر. Is the change the same as the change that happened to concentration? ولا there is no change at all? Somebody tell me, is the change in the rate of the reaction is the same as the change that happened to the concentration? ولا there is no change? So when you say no change, means what? Means no change in the rate of the reaction. In the rate. يعني ايه يا مستر؟ يعني كانت مثلا 0.160 وفضلت 0.160. So somebody tell me, is it the same change ولا no change ولا power 2? Same change ولا no change ولا power 2. يلا ما تخافوش, don't worry يا جماعة, answer. No problem of making mistakes. Is it the same change? Is the rate of the change is the same
Yes.
as? Yes, it is the same. Yes, very good, thank you. Whatever happened to the concentration, it is halved, and also the rate of the reaction is halved. So don't tell me no change. ناس كتير تقول لي no change, it's halved and halved. No, I'm not telling you about the comparison ما بين concentration and rate. I'm telling you, is the change that happened, خد بالك, اللي change, the change is happened, yes, it is the same. امال امتى اقول عليها zero order يا مستر؟ اقول عليها zero order امتى عبد الرحمن? when I say zero order, if this is halved, so this is second order, this is first order. If I say the concentration is halved and the rate no change, this is what يا عبد الرحمن? This is what? Is this first order ولا zero order? This is what? The rate of the reaction, this is zero order. Why did I say zero order? Why did I say zero order? Because there is no change happened. So don't say zero order except when there is no change in the rate between experiments. طيب, what if I said, يا Miriam, that here was halved, here was divided by 1 by 4. Divided by 4. This is what, Miriam? This is what? Is it first ولا zero ولا second order? Am I silent, guys? Is the change the same or powered to 2?
Power to 2.
power to 2. So if it is power to 2, what I will copy take Miriam? If it is power to 2, I will take what?
Second order.
Second order. So I will take second order. Very good. So I will take second order. Tamam. So let's do it by the example. Let's not just say it theoretically. Let's do it by the example and say what I will say exactly. Let me say again, yeah, mister. Okay, let me say again, and then please delete all that. Delete all of that. Abdurrahman, I need you with me. So tell me, Abdurrahman, what happened exactly to the concentration? Okay, first, Abdurrahman, I will pick two experiments. So I'll pick any random experiment, 1 and 2. What happened to NO, Abdurrahman? I will ask you many questions. I need you to open the mic and answer all of them. Huh? One of the fire questions.
Okay, 1.
Okay, 1 and 2. What happened to the concentration of NO? Between 1 and 2, what happened to the concentration of NO? Did it change or no change?
No change.
No change. And what happened to the rate? Divided by 2. Divided by 2. طيب مستر, this means that this is fixed. يبقى انا مش هستخدمها. وما انت ليه مستر استخدمتها؟ Oh, I need to make one of them fixed يا عبد الرحمن and one changing. ليه؟ Why you are doing like this يا مستر؟ علشان لما يحصل change, so when the change happens, I will know that this change is because of the change in H2. I don't want them both to change. If I make them both changed, I will be confused. Like if I picked 1 and 3, 2 and 3, then there is change here and change here, right? صح يا عبد الرحمن?
Yes.
So I will not know this change, the rate of the the change in the rate is because of the change in the first reactant or second reactant. I will be confused. So I will stop one of them from changing and make the other one change it. So 1 and 2, this one is changed. What happened to the rate of the reaction? Nothing. طيب 280 and 145. What happened, Ya Abdurrahman, to the concentration? Concentration of H2 is divided by
2.
2. And the rate is also divided by 2. So I will say, Mr. Rate is equal to K, and then H2 concentration, zero order ولا first order ولا second order? Is it the same change ولا no change in rate ولا divided by 4? أنا كان عندي 3 حالات. لا إما التشينج في ال H2 when it is divided by 2 الريت no change ولا divided by 2 برضو ولا divided by 4. أنا اخترت أنهي واحدة فيهم يا عبد الرحمن؟ divided by 2 برضو. So what will be the order?
Divided by 2.
Divided by 2. So is it 0 ولا first ولا second? The same means first. If it is the same means first. هنا divided by 2 وهنا برضو الاثنين ايه يا عبد الرحمن؟ الاثنين ايه؟ divided by 2. Here divided by 2, concentration divided by 2, rate divided by 2. If it is the same, so it is first order. If it is powered by 2, if it is power 2, then it is second order. If there is no effect on the rate, then zero order. انت رأيك ايه? What do you think? Is it the same? هنا divided by 2, هنا divided by 2, صح؟ مش الاثنين divided by 2?
Yes.
So it will be first or second or zero?
First.
First. طب امتى يا ياسين؟ Very good. امتى يا ياسين I will say it is second order لو كان الريت ايه؟ divided by كم؟ by 4. طب
by
صح؟
4.
by 4. امتى يا مريم I will say it is zero order if the rate is what? If the rate is what? If the rate is unchanged. صح؟ If the rate is unchanged. لو صح يا مريم؟ If لو كان 0.60 وهنا 0.60 it will be what? Miriam, it will be what? If the rate not changes 0.160, it will be zero order unchanged. صح؟ So if it is 0.6 ساعتها هقول Mr. changing the concentration of the H2 did not make any change. So if there is no change, I will write it for the last time. So if the concentration change causes no change in rate, it is zero order. If the concentration change caused the same change in rate, يعني divided by 3, so it is first order. If the concentration change is actually powered by 2, it is second order. So I will say that this is first order. طيب, what about the rate law compared? What about the rate law compared to? So I will just, what I will say, Mr. I will say K and H2 to the power of 1. So K to the H2 to the power of 1. طب Mr. what if it is complicated? What if it is complicated? What does it mean complicated? يعني ايه complicated يا ياسين? It means that there is change in both of them. أعمل إيه؟ أقول له لا ما ينفعش في الامتحان. I will tell him no. If it is changed for both, what I will do? Does anybody know? يعني for example, I need to know what is the effect of changing. I need to know what is the effect of changing X, NO بس. So Mr. I have to stop H2 from changing. But Mr. I can't. Whenever I try to find an experiment in which the two experiments in which H2 is not changing, I don't find. طب أعمل إيه يا مستر في الحالة دي? What do I do in this case? Every time I try to find, take care. احنا قلنا in order to find for one, you have to stop the other one from changing, right? When I try to find the rate relative to, خد بالك أنا عملت غلطة. I made a mistake. No, I didn't. It's H2 صح? It's H2. No, I need to find it relative to NO بقى يا عبد الرحمن. I need to find it for NO. So I have to stop this one from changing. But أعمل إيه يا مستر? When this one changed from here to here, this one changed. ده رخم قوي. And طب بدل ما 2 و 3 اجرب 2 و 3, let me try 1 and 3. When this one changed, what happened يا عبد الرحمن to H2? It also changed. انا عايز اثبت بقى. I need to focus on NO alone عشان اكتبه بقى. In order to find its rate low, I need to focus on this one. What to do, yeah, Mr.? There is no chance. So I have to make another method. I will look at 1 and 3 and focus on them. When the concentration of NO was 400 and changed into 200, the concentration of 289 changed into 290, and the rate low changed from 0.260 to 0.0440. مستر ايه اللي انا همسحه؟ ايه اللي انا مش عايز ابص عليه دلوقتي يا ياسين؟ Which one I don't want to look at now? I don't want to look at H2 خلاص. I don't need H2. I found its rate low, right? I found its rate low. So now I need to know what happened when I changed the concentration of 400 into. انت قلت مسحت ده يا مستر. Yes, I deleted this one. I need to know what happened when you changed the concentration of NO from 400 into 200. The rate of the reaction has changed from 0.160 into 0.40. هل ممكن اعتمد على دي؟ Can I depend on this Miriam only? Can I depend on this only or I can't? I cannot, yeah, Mr. Unfortunately, I cannot. So I cannot just say this is divided by 2 and this is divided by 4. Take care. This is a very common mistake. It happens a lot in the exams. The student says, now I need to know what is the power of H of NO. I will say, this one NO has been divided by 2 and this has divided by 4. So it is second order. Can I do like this, yeah, Abdurrahman? No, yeah, Mr. Why I cannot do, Abdurrahman? Why Miriam? Why Yasin? Because here, yeah, Mr., this one has changed also. So the rate change also depends on H2. I cannot separate them from each other. But why did you do this in the last time? The last time was different, yeah, Mr. When I changed this one, this was constant. طب ايه الحل يا مستر خلصني؟ The only way to do this is to write this equation. Have a look. ركز كويس جدا. Focus very well. I will say like that. When the rate of the reaction was 0.160 and changed 0.040, حاجتين حصلوا. Two things happened. ايه الاثنين اللي حصلوا؟ The concentration of the H2 changed from what to what, Yasin? 289 into what? خد بالك I'm
On the
focusing
first part.
into 290 right صح؟
اه.
focus, we are doing experiment 1 and 3. And what happened يا عبد الرحمن to the concentration of the HNO? What happened to NO from 1 to 3? It changed from what to what? From
From
400.
289 to 145.
ده ال H2. ده ال H2 احنا كتبناه خلاص. I need to for NO. It changed from what to what?
400.
From 400 to 200. So do like that. I will say 0.160 على 0.041 equal to K equal to K equal to K يا مستر of sorry I will say K over K. يبقى الرول بتاع ده على الرول بتاع ده 400 بقى 200. بس ال 400 وال 200 انا عرفتهم I knew them already فمش محتاج لهم. امال انا محتاج لمين؟ محتاج لده بقى. عايز اعرف ده. عايز اعرف ده باور كام. This one I know it خلاص. I don't need it. It is first order صح؟ انا مش عايزه. انا عايز مين يا ياسين؟ I need this one. So I need to find M او X او N or whatever you wanted. Again, why did I did not put this one يا ياسين؟ Because خلاص it is 1 to 1 صح؟ It's 1 to 1 مش كده؟ I know it's power 1. How did you know it's power 1 from the last one يا مستر here? You said it is power 1. How did you know? Because it was the same change. So I will just write the equation for both of them. يا مستر the rate is equal to K في concentration of NO. والريت الثاني بتساوي ما هو ده الريت له K في الكونسنتريشن اوف NO the second time. بس ما انساش. طيب وال H2 يا مستر I found it already. H2 was power 1 power 1. طيب what is the power يا مستر؟ So it is power M and power M. What is the rate? Let's do a rate. الريت يا مستر is equal to what? It's equal to 0.16. حد يحسب لي 0.160 على 0.040 بيساوي كام؟ 0.160 يا مستر على 0.040 is equal to 4. 4 حلو. يبقى الريت بتاع ده يا مستر الريت بتاع ده على الريت بتاع ده بيساوي ايه؟ 4 ها؟
4.
4 خلاص. والناحيه الثانيه الكالكوليشن يديني ايه؟ 289 اوفر ام وال 290 اوفر ام. هشيل ده يا مستر بقى وهعمل ايه؟ 289 اوفر ام وهشيل ده وهشيل ده وهكتب هكتب كام؟ 400 على 2. 400 على 2. ال 400 مش دي كانت 400؟ 400 على 2 يعني 2 يا مستر. to the power of كام؟ مش عارف. to the power of كام؟ مش عارف. what is the power؟
2.
2. So it is power 2. I know it's confusing, so let's do it one more time and one more time and one more time. I will say the rate of the first one. The rate of the first one على الريت بتاع التاني بتساوي كام يا مستر؟ بتساوي 0.160 على ال 0.040 يعني 2 يعني سوري يعني equal to 4. وبعدين يا مستر هقول equal to الريت بتاع ده على الريت بتاع ده. كي مع الكي كانسل الكي مع الكانسل الكي. طيب ال NO concentration مع ال NO concentration كانسل دي مع الكانسل دي. كنسلتهم ازاي يا مستر؟ مش الكونسنتريشن واحد. مش الكونسنتريشن واحد يا شباب. ال NO changed ولا unchanged؟ ده الريت يا مستر بتاع ده to the power of ده. سو هكنسل دي وهكنسل دي وهحط اللي انا عارفهم 400 على 200 واعملها. يا ترى ال 400 على 200 to the power of كام؟ to the power of كام؟ to the power of كام؟ يبقى ايه الرقم؟ what is the number؟ what is the number that 4 is equal to which number؟ which number؟ So 2 to the power of which number? So 2 to the power of which number? So 2 to the power of it. يبقى m is equal to 2. So it is second order. So can I write the full equation, yeah, Mr. Now? Yes, I can write the full equation. The rate of the reaction depends on the concentration of H2 to the power of 1. يعني أي تغيير يا عبد الرحمن هعمله للكونسنتريشن هيحصل نفسه للريت. وأي تغيير هعمله للNO هيحصل باور 2. What will happen يا مريم if I multiply the concentration by 2? The rate will be multiplied by what if I multiply the concentration of 2 of NO by 2? The rate will be what يا مريم? Will be power will be multiplied by
4.
4. Very good. ممتاز. وياسين, if I divide it by 6, what will be the rate divided by
36.
36 to the power of 2? Okay. The last thing that we will take today, we will not take the integrated rate law. Today we'll take it on Tuesday, inshallah. How can find the unit of the rate constant? The unit of the rate constant. What is the unit of the rate constant, mister? The rate constant is K. What is K? You said rate is equal to K multiplied by the concentration of A, which is the first reactant, whatever this reactant is, to the power of N. معرفش هيطلع كام, 0 or 1 or 2, and B to the power of M. معرفش هيطلع كام, 0 ولا 1 ولا 2. طيب, can I find K? What is K? What is K? K is equal to the rate of the reaction divided by الحاجات دي. How did I do this? I just divided both sides by the same one. I divided this by A to the power of N P to the power of M and divided it by the same. فطلع لي يا مستر الكي بتساوي الريت على الاي. طيب, واضح يا مستر ان الكي دي مش هتطلع في كل الاوقات نفس الحاجه. ليه يا مستر؟ ليه؟ ساعات الان تكون to the power of 1. فساعتها معنى ذلك ان الريت بتاع الكي if it is to the power of 1 يا عبد الرحمن يعني ايه؟ وما بيعتمدش على البي خالص, يبقى الريت هتساوي كي في ايه. طب لو الريت بتساوي كي اي 2, معنى ذلك ايه يا عبد الرحمن؟ انه بيعتمد على الكونسنتريشن بتاع الاي بس, مش البي بس في which order؟ second order. او ممكن يطلع الريت بتساوي كي اي بي, معنى ذلك ايه؟ it depends on the concentration of A and depends on the concentration of B, and both of them which order يا عبد الرحمن? first or second or zero? both of them is what? first. او ممكن يطلع كده, كل الحاجات دي بتطلع depends on what. احنا قلنا depends on what يا ياسين. how can I find this? انا بيطلع لي الكلام ده ازاي؟ من الارقام دي يا مستر. so experimentally, only experimentally. يعني ايه يا مستر؟ يعني you have to give me these numbers and then after that I will find the rate law. if you don't give me these numbers you cannot get it. لا يا مستر, ممكن اجيبها بالcoefficient. No, I said we cannot depend on the coefficient. خد بالك عبد الرحمن, can I ask you a question? Can I just say that NO is second order? Can I just say that NO is second order? Yes or no?
No.
No. Very good. It does not depend. Yasin, can I say that H2 is first order or second order by looking at this equation?
لا.
لا, ما تعتمدش. It does not depend on the coefficient إلا في الحتة اللي احنا قلنا عليها بس. Unless we are speaking only about the part that we talk about اللي هي مين? Which is what? Which is the rate determining step by the mechanism. Okay? طيب, unless than that, then ممكن يطلع أي حاجة بالاكسبيرمنت. ممكن يطلع إيه تاني؟ option تاني إيه؟ What other option can come يا مريم? K A to the power of 2 and B to the power of 1. You see how many options? Rate is equal to K to the power of B. where is A, عبد الرحمن? Where is A? There is no A. So this, what does it mean, عبد الرحمن? If there is no A, what is A is to the power of كم? Which order? If it is
nothing.
Yeah, it is 0. It is 0. If it is not showing, it means it is 0 because A to the power of 0 is 1. So what does it mean, Yasin? What does it mean A to the power of 0? It means that changing the concentration بتعمل ايه؟ بتعمل ايه على الريت؟
No effect.
No effect on the rate. صح؟ Don't forget. So 0 order means no effect on the rate. كل الاوبشنز دي موجوده يا مستر. في اي اوبشنز تاني؟ حد يعرف اي اوبشنز تاني؟ K A to the power of 2 P to the power of 2. يعني اي تغيير هتعمله في ايه هيحصل to the power of 2 في الريت, واي تغيير هتعمله. يبقى معنى ذلك ان الكي هي كمان ممكن ما كل مره اطلع الكي, صح؟ كي از ايكوال تو ريت على الكلام ده. يبقى معنى ذلك ان في اوبشن واحد للكي يا مريم ولا ميني اوبشنز؟ There is many options. There is many options for the K. So this means that the unit of the K depends on this. So the unit of K depends on which equation you will be using. ازاي يعني يا مستر؟ يعني لو الريت is equal to KA only, rate is equal to KA only, K is equal to rate over A. What is the unit? واحد هيقول لي what is the unit يا عبد الرحمن؟ Let's see together. What is the unit of the rate of the reaction? What is the unit of the rate of the reaction يا مستر؟ مش الكي، اليونت.
اليونت.
يس، اليونت بتاعت الريت. احنا قلنا الريت هي التشينج ان وات؟ concentration over time، صح؟ What is the unit of concentration؟
M.
M. What is the unit of time؟
T.
T. حلو، ده اليونت بتاعت الريت. طب what is the unit of concentration again اللي تحت دي؟ هم؟ هي يا عبد الرحمن what is the unit of the concentration again؟ انا عندي
M.
M تاني، صح؟ M تاني. Then I will cancel this one and this one. What will be the unit يا عبد الرحمن؟
Time.
T minus 1، صح؟ T minus 1 بس. طب ينفع اقول can I say يا مريم it is the same thing if I said rate is equal to KA squared? Is it the same thing ولا it will be different؟ It will be different يا مستر. Why? Because K here is equal to rate over A squared. Can you tell me مريم what is the unit here? What is the unit of the rate of the reaction? Rate of the reaction, what is the concentration over time? So what is the unit of the rate of the reaction يا مريم؟ It's molar over what is انا بعمل واحده يا مستر. You are making one. So again, this is the unit of the rate. So this is the unit of the rate. It's molar over time. And امال الام الثانيه جت منين يا مريم؟ It is the unit of the concentration. Okay. So can you tell me the same thing? I will divide it for you. This is the unit of the rate. What is the unit of the rate? And what is the unit of the concentration squared? What is the unit of the rate? Miriam, what is the unit of the rate? Are you still here?
Moles per time.
Mole over time. حلو جدا. And what is the unit of the concentration? One time is what? Again, molar بس.
Moles
molar. بس المولر المرة دي كم مرة؟
squared.
Twice. So it will be molar and molar again. So I will cancel one of this with one of this. What will be the unit? What will be the unit يا مريم؟ time ولا time minus 1؟
Time minus 1.
وm ولا m minus 1؟
Minus 1.
ممتاز جدا. So the unit differed، صح؟ اليونت يا ياسين اتغيرت، كانت هنا time minus 1 m minus 1 وهنا time minus 1. طب if I told you يا ياسين that rate is equal to K A multiplied by B. What is that? K is equal to rate divided by concentration of A multiplied by concentration of B. What is the unit ياسين؟ Let me do the colors for the previous one.
minus 1.
لا اديني فرصة اعمل الالوان، انا عجباني الالوان دي قوي. So this is the colors and then this one. So what is the rate يا ياسين؟
M minus 1, S minus 1.
M minus 1 S minus 1. حلو جدا. So M minus 1 S minus 1. هي S ولا T؟ حسب اليونت، صح؟ حسب اليونت. So if it is second it will be S minus 1. If it is minute it will be minute minus 1. If it is hour it will be hour minus 1. It depends on what he is giving you for the reaction، صح؟ So this is M over، ممكن تفصلها لنا ياسين؟ Can you tell us how did you get it؟ M over what؟ M over
M squared.
الأولانية الريت كانت إيه؟
M over S.
M over S. حلو. والتانية
M squared.
M squared. So you canceled one of here مع 1 من دي وطلعت M minus 1 S minus 1 زيها زي اللي إيه؟ زيها زي دي بالظبط. Same like this one, right? Same like this one. So it's appearing that واضح جدا إن اليونت the unit of the K، كل احنا بنحسب إيه؟ What we are calculating the unit of what؟ The unit of K, right? The unit of the rate constant. It depends on your equation. So you have to find it from the equation. Okay. Okay. Oh, that's it. We'll take questions. Any questions related to anything? This chapter, this unit, any unit, anything? We are having one more session today at night at 8 p.m. to explain, to revise. It's a little bit more SABS related, but this will be at 8 p.m. and it is for unit, which unit we said? Bismillah. Yeah, this I will decide later. It will be more for, I think it will be for unit 8. Yeah, it will be for unit 8 at night. Okay, we are still going, but this is mainly for the SABS revision for the SABS school. Okay, questions? Questions? Any questions? Okay. So next time, inshallah, we will be answering more questions. Please be sure that you understand everything that we explained today, because we'll be answering more questions, and then we will take the integrated law. لو عندنا وقت. If you don't have time, we'll say the integrated law for the last time, because I think this unit will take 3 sessions or 2. I'm not sure. Okay. Thank you so much, and see you next time. Still waiting for the questions until 5:30. Unless that, you can go if you wish.